In this video, we're going to take a look at the Model Mania Design Challenge from 2007. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this and they're tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're done with the part, they're given a second drawing, or Phase 2, where they're required to make several changes to it. In this particular video, we're going to look at how to create this part two different ways using more traditional methods where we create each feature one sketch and one feature at a time, and then a second way where we use something called contour selection. We'll then go ahead and look at how the different ways we created these impact making those design changes. These parts are actually fairly simple to create, and because we're showing two of those, I'm going to be going through this rather rapidly. So let's dive right in and let's look at that first method, creating this using more traditional feature by feature geometry creation. For this, I'm going to go ahead and start with the cylindrical feature on the bottom of the part. It's an 80 millimeter diameter and it's simply extruded 80 millimeters back. I'm going to go ahead and just drag that out and get that feature there. Now the next thing I'm going to do is I'm actually going to go ahead and I'm going to create the cylindrical boss feature that's up near the top. And for this, I'm going to go ahead and draw a circle. The dimension is given to us in radius value, but because we're drawing a circle, we need to enter a diameter. So I'll just multiply that by 2, which is 50. Now always remember you can right click on a diameter, go to display options, and choose to display it as a radius if you'd like. Then we just simply need to locate this given the dimensions on the drawing, 40 millimeters from the back and 100 millimeters from the center of our part. Then we're just going to go ahead and simply extrude this. Now it's symmetric from the middle of the part, 50 millimeters, so we're just going to change the end condition to be mid-plane to create that. The next piece, this rib feature, we're going to also create on the right plane. And I'm going to show one of the pitfalls that a lot of users run into when drawing down the center of a circle. They like to create geometry from the top center, and we're going to go ahead and show what happens when you do this. I'm going to draw some tangent arcs. Now notice tangent arcs by default like to come straight out off from that line, but you can also, if you go back, you can draw them straight out from the top, creating a perpendicular arc instead. We will need to go ahead and have to add that second tangency relationship, however. So let's do this again on the back, and this time we're going to draw two tangent arcs and again make those tangent and add the radius values that we saw on the drawing here. Again, this is going to be 50 and this will be 200. And I'm going to go ahead and trim this up. Now what happens is when I go to extrude this, the 20 millimeters, and again we're going to use mid-plane, you'll notice in the preview that the geometry actually doesn't intersect the part. And what happens here is it creates what's called a zero thickness geometry condition, where there's actually a spot where the parts are tangent to one another, and as a result we end up with two solid bodies. Now there's a couple ways of fixing this. You could draw a sketch on the bottom and extrude it down into the part, but one of the most common ways to tackle this is instead of drawing this line, which we'll delete, is to just create geometry that goes into the part. In this case, I'm going to go down to the center line of the part, and we will have to go ahead and make one minor change. When we created that extrusion, SOLIDWORKS could only find one body that it could merge with. When we did that, it had this feature scope option was set to auto select. All we need to do is change this back to include all bodies and it'll all be joined together. Then we're going to go ahead and just create a series of bores here. These are actually really simple to create. We're just going to draw this first one at 30 millimeters, which we'll go ahead and then do a cut through all. And then the same thing on the front right here. We're going to go ahead, draw a circle. This one's 50 millimeters, and we'll go ahead and do a cut through all on that as well. Then we're going to create this keyway on the front of this part. And one of the easiest ways to do this is to just draw a rectangle. You can copy or you can enter that width right away, but the height will deal with a slightly different way. We're going to go ahead and add a midpoint relationship to the center of our part, and notice how that locks that in on the center. All that we have to do then is dimension from the top to the bottom of this circle by holding down the shift key, and we can enter that 55 millimeter dimension. Then like before, we'll just choose to do a cut through all to make sure it always terminates the part. Finally, we'll add some fillets. These larger ones, which are 50 millimeters, we're going to create first. And the reason we do that is so when we add the 4 millimeter fillet, when I select this face, tangent propagation automatically captures the rest of that rib feature for us. I am going to change the color of this to make it a little easier to distinguish those 4 millimeter fillets. I selected the wrong ones. Let's go ahead and select the right ones in this case and make those red. So in the first way we created this, we used very traditional modeling techniques, feature by feature, and we ended up with 8 features with 6 unique sketches in here. What I want to look at now is a different way we could create this as well, using something called contour selection. With contour selection, we can add a lot more geometry into a single sketch. And for the first cylinder feature, I'm actually going to use this using a revolve. So we might create our geometry, but notice I'm also going to create a center line. The center line will be valuable when we create the revolve for an axis of revolution, but it's also useful for dimensioning a diameter. Notice when I dimension from this line to the center line, it is by default giving me a radius value. But simply moving my cursor to the other side allows me to instead dimension the diameter. So I'm actually capturing the dimensions as they were intended. And like before, we're going to draw this this top boss, but we're going to all do this in one sketch instead of 2 separate sketches. This time, however, we will dimension to sketch geometry as there's no solid geometry to dimension to, but the process is nearly identical. And then finally, we're going to go ahead and add those same tangent arcs we did before. Oops, I accidentally missed something there. And like before, we'll have to add that tangent relationship, and then we'll do the same thing on the outside that we did before. Again, just to sketch geometry. Nothing's really different about this, just the way we're creating it. So let's go ahead and add a 200 here. But we have all this sketch geometry in one single sketch. Now this has a lot of advantages. I'm going to go ahead and start by creating a revolve boss. And if you remember, the center line I created was automatically selected as the axis of revolution because it was the only center line in the sketch. When you work with selected contours, however, SOLIDWORKS allows you to select anything out of the sketch. For example, the center of this arc, this ring shape if we want, this internal region. But what we're looking for in this case is to create that whole cylinder in one feature. Now the sketch is gone and we already sketched all that geometry, but you could always access it by selecting it out of the feature manager tree. I'm going to show this for clarity. I'm going to go ahead and select this, and this time I'm going to go ahead and choose extrusion, and instead I'm going to choose the center region. Like we did in the previous example, I'll set this to a midplane, but be careful because you could run into the same challenge you did before, in this case not having any material intersect. So for this, I'm going to select an additional sketch region. Notice I grabbed this rectangular area. And that creates that for us. We're going to do the same thing again. I'm going to pre-select the sketch. You don't have to pre-select. You could actually select this circle, for example, and choose extrusion. And then go ahead and select the inside circle to remove that area. Again, let's go to a midplane and let's set the width to 50 millimeters. So we've created 3, actually really when you think about it, 5 features from one sketch if you count the bores as separate features. I'm going to go ahead and hide that and then just create the last of those fillets like we did before. I'm going to go ahead and, I didn't want those 2 extra edges. Create that there. And then we're going to go ahead and select these faces just like we did before and change the colors. So there we've created it very differently than we did before. We created almost everything in a single sketch. And then we created only 5 features this time. Actually, that's why we're missing a feature. We do need to create the keyway. I want it to happen before these fillets. So let's go in and add that. Knew I was missing something there. We're going to do this just like we did before. We're going to add a midpoint relationship and we're going to dimension from this line and hold down shift and dimension to the bottom of this circle. And then we're going to go ahead and cut that through all. Now I just like my fillets to happen at the end because a lot of times changes can impact them. This drawing, or this part in particular, they don't. So there we go, 6 features, 2 unique sketches. One that captures the bulk of it and then one for the keyway. So now let's go ahead and take a look at how the changes are going to affect this. When we look at the Phase 2 drawing, we can see that the part has changed drastically. Everything we tried so hard to keep in the center of the part has been shifted over to the right side. In particular, that top boss starts at the left side of that rib feature and extrudes out. You'll also notice that the keyway has been rotated 40 degrees and the fillet has been changed to 25 millimeters and an additional edge has been included. So let's go into SOLIDWORKS and let's take a look at how we do these changes on the first example we created. One of the easiest things to do is to first roll back to the beginning of your part and tackle this feature by feature. The first feature, this boss, won't be affected by any of these changes, but the next one will. This needs to actually reside 20 millimeters off from the tangency on the outside. Well, we don't have any geometry out there to work with. If we roll back in our feature manager tree before the boss was ever created, we can add our own plane to SOLIDWORKS using a reference plane. For this, I'm going to create a plane that's parallel to my right plane and tangent to this cylinder. Now when we roll back down, we can make changes to these features and we can change the plane that this sketch was created on by choosing the Edit Sketch Plane option. I'm going to choose to create this sketch instead on plane 1. Notice what SOLIDWORKS did. It moved the feature and maintained the mid-plane end condition. All we have to do is go ahead and change this and instead make it blind. But there's still a problem. This feature should be 20 millimeters offset back from that tangency. For this, we're going to access the From option and change this to offset 20 millimeters and we'll just reverse the direction. So now that's in the proper location. We'll do something similar with this next feature, but we're going to do this a little bit different. We're going to change the plane that this sketch was created on to the same plane we did before. And like before, we're going to edit this feature and change this to be blind and set the direction correctly. Now everything looks good, but what happens if that 20 millimeter dimension were to be changed to 25? You end up with needing to change this dimension in two separate places, and we don't want that. What you can do is instead change the end condition of this rib feature to be an up to surface by simply double clicking on this face. Now I only change this dimension in one place and it's updated in both locations. That's a great way to add some intelligence to your designs. What about some of the other feature changes? First, the top bore through the top cylinder doesn't change at all. Neither does this bore here. The keyway, however, does need to be rotated 40 degrees. We're going to look at one way to do this here, and we'll look at an additional way in the next example. The first way you can do this is by using the Rotate Sketch Entities option. To do this, you just simply choose Rotate Entities. This can be found under Tools, Sketch Tools. I've added it to my command manager for convenience. And we're going to go ahead and choose a point of rotation, the center of our part. Then we just specify the orientation we want to rotate it, in this case 40 degrees to the right, and press OK. The problem with this method is look what's happened. It's actually deleted all the relationships that kept it where it was before. But this is easily fixed by simply right-clicking and choosing Fully Defined Sketch. I'm just going to accept the defaults here, but notice what SOLIDWORKS did. It dimensioned from the outside to this point. That's not how we want to define this. We want to dimension this from the right plane to one of these lines, and the 40 millimeters is there. But do notice that when we did that, SOLIDWORKS made these lines parallel to one another and these lines perpendicular to that first line that we had created there. So it did take care of the rest of the work for us. The rest of this is pretty easy to update. This fillet needs to be changed to be a 25 millimeter radius, but you'll notice it does need to be added to that edge there. So I'll choose to edit this feature and I'll select that edge. And then when we roll down, the rest of the fillets do update automatically because we did in fact choose faces instead of edges. So you can see we were able to go through and we were able to make the changes pretty easily using a reference plane. If we take a look at the other example, we're going to be presented with some different challenges. Because this plane was created on the right plane and so many features reference it, we really can't move it because of this revolve feature. So how do we solve this in this case? we're going to approach this in a fairly similar manner. We're going to roll back and we're going to create a reference plane that, like before, is parallel to my right plane and tangent to this cylindrical feature. However, when we go to this feature, instead of moving the sketch to a different plane, we're going to use that from option. In the from option, we've looked at offset, but this time we're going to choose to use a surface, face, or plane. And we're going to choose this plane as where we want to extrude from. Like before, we will change this to be blind and we'll want to reverse the direction. Now notice what happens when we do this. SOLIDWORKS, because of the contours we selected, has left a gap here. Now we could solve this one of two ways. We could edit the feature and we could choose to add that additional region to the bottom, but that creates some additional material on the inside. This is easily fixed by simply selecting the two faces and choosing to delete them, and SOLIDWORKS will take care of all that. Another way we could have done this is using the same move face command we saw before, but instead using the translate option. For this, I'm going to choose that face, and notice under parameters you can choose up to surface. In this case, I'm going to choose the outside of the cylinder and simply extend that face up to the geometry there. Then we'll go ahead and take a look at our next feature. Now this time, again, we could choose the offset option, but we can't do both a from plane and then offset it back. So how do we fix this one? In this case, instead of using offset or surface, face, or plane, we're going to choose the vertex option this time. And here we're just going to simply choose this vertice here and again change the end condition to blind. And notice that's really easy to make that fix. From here, the rest of this, we're going to look at this keyway. We're going to approach this one in a very different manner than using the sketch rotate. For this one, we're going to look to move face again. And this time, instead, we're going to use rotate. I'm going to select these three faces. And when we choose rotate, we can specify a center line. What I want to do is show my temporary axes. SOLIDWORKS creates a center line on every cylindrical feature in your part. And I'm just going to choose this one here and set my angle to be 40 degrees. And you can see the preview. We want to flip the direction to the other side and press OK. And we were able to do that using move face this time. I'm going to turn off those temporary axes. From here, the rest of the changes are very similar to what we did before. We changed the radius to 25 millimeters and add the additional edge, and then just simply roll to the end. So as you've seen, we've created this part two very different ways, and the different ways we've done this have affected the way we make the changes to the part. In doing this, I've shown that you can create parts and features in SOLIDWORKS a variety of different ways. Don't ever feel like you're limited to creating something one particular way. There's always multiple ways of doing something inside of SOLIDWORKS. If you like this video and you want to learn more about Model Mania and SOLIDWORKS World, please visit the link below in the description of the video, or if you're watching this on the technical blog, in the blog post itself.